Hello, today we are going to take a look at how point mutations in DNA affect the resulting amino acid sequence. First, we have to find the region of DNA that codes for our 4 amino acid long sequence. For the 3' to 5' DNA strand, the resulting 5' to 3' mRNA strand would code for a 5 amino acid long sequence. Since we only want 4, we need to look at the other strand. We have to rewrite the mRNA strand from the 5' to 3' DNA strand, so we can look for codons for amino acids in the 5' to 3' direction. Once written, we find the start codon a few base pairs down. Since this sequence is 4 amino acids long, it's the one we are looking for. The bottom strand is our coding strand since it will exactly match the mRNA strand, except for the exchange of uracil for thymine. A point mutation is when a single base pair is switched to another base pair. There can be a transition point mutation where either a purine is exchanged for a purine or a pyrimidine is for a pyrimidine. There is also a transversion point mutation where a purine is exchanged for a pyrimidine or the other way around. This strand is wild type since no mutations have occurred. Let's examine how point mutations in the coding strand will affect the resulting amino acid sequence. First, we have a missense mutation, which causes one amino acid to change to another. If this doesn't affect the function of the protein, it ends up being a neutral mutation. A transition from adenine to guanine in the coding strand causes a codon in the mRNA to read GGC instead of AGC, changing the serine to a glycine. The chain still has 4 amino acids, however one is different from the wild type. Next, we'll look at a silent mutation, where there is a change in the base pairs but the resulting amino acid stays the same. A transversion of cytosine to guanine in the DNA coding strand results with a codon in the mRNA reading GUG instead of CUG. However, both of these codons code for valine. The amino acid sequence remains the same as the wild type. Third, we have a nonsense mutation. A nonsense mutation causes a stop codon to be coded earlier than in the wild type sequence. Here we see a transversion from an adenine to a thymine in the DNA coding strand. In the mRNA, the codon reads UAG instead of AAG, making the amino acid sequence stop there rather than code for lysine. The mutant amino acid sequence reads methionine, valine, serine, stop, ending before the wild-type amino acid sequence would. Finally, we have a read-through mutation. With a read-through mutation, the stop codon changes to another amino acid, so the sequence continues on longer than the wild type. In the DNA coding strand, there is a transversion from an adenine to a cytosine. This causes the mRNA to read UAC rather than UAA. Since UAA was the stop codon and it changed to UAC, which codes for tyrosine, the translation complex doesn't get the signal to stop and continues coding amino acids. Those are 4 ways point mutations can affect an amino acid sequence. Here are my works cited. Thank you so much for watching.